Good morning to everybody. Today's topic is work, energy and power. So today I will explain you work. What is work? See, in our daily life, if we say that I am doing some work, just I am reading or I am going somewhere else, it means for reading purpose and for going somewhere else, you do some work in the form that energy is lost in doing the work. Suppose you are reading, it means there is a loss of the mental energy, and if you are doing some work in another way, then there is a loss of the physical energy. So the point is that during some work done by the humans in daily life, there is an exhaustion of energy. But in our physics, what is work? In simple way, if you push a stone, a heavy stone, again you push it, the stone moves and cover a certain distance. Listen, if you push a stone, the stone moves and it covers a certain distance. It means work done by a stone to move certain distance. Here the force is the energy. Listen, when force is applied on this heavy stone, this stone moves and covers some distance. Now, why stone moves? There is a push, and push is in the form of the energy, as in the case of the daily life. So, the object covers a certain distance. So, we say that the work done is due to the force which covers the distance. So, we say if force is applied on an object, it covers a distance up to B, then the work done by A to move to cover certain distance is the product of force and the distance. Here we say, as in the daily life, I tell you that force is in the form of energy. In the same way, the force applied on the object is the energy which moves the object to cover certain distance. So we say that work is said to be done when the force applied on the body moves and covers some distance in the direction of the force. So the point is that force applied on the object moves and covers some distance in the direction of the force. So here work done is equal to force into distance, that is the displacement. Now suppose you are pushing a heavy stone does not move, it's too heavy. Then what will happen to the work done? Here, as work done is the product of the force into distance, here distance is 0. That object is very heavy, you can't push it. In that case, work done, that is force into distance is 0, then there will be no work done. For example, a man is standing having some load on his head. He is standing just, he is not moving. Though he is feeling some tiredness because load is on the head, but there is no displacement, he is not moving. In that case, work done will be 0, because we know that the force, that is work done, is equal to force into distance, here displacement is 0. Now, think one more thing, that if force is applied on the object and the displacement is in other direction than the direction of the force, I will say that the displacement is inclined in upward direction. So suppose if force displaces the object in other direction instead of the direction of the force, suppose a object, force is applied in the direction of the AB, but it displaced in the direction of the AC, that is the displacement is toward the C point. Now here, how we calculate the work done? You see, work done is force into the displacement in the direction of the force, but here displacement is in inclined way, that is AC, and force applied is towards AB. Now here, draw a perpendicular from C to B. Now you will get a triangle, right angle triangle, that is CAB, where displacement is AC and force is the direction of AB. Now this angle which is formed at A, and we have to find the AB, then this angle theta, that cos theta is equal to AB upon the AC. This angle formed by the displacement to the point of the force, and we have to determine the AB. Then CAB is cos theta, and cos theta is equal to AB upon AC. Now work done is equal to force into the direction, that is the displacement AB. So work done is equal to F S into cos theta. So whenever the displacement is inclined to the direction of the force, then the work done is equal to force into distance into angle cos theta. Now depending upon the angle, there are three conditions. If theta is 0, that is displacement is in the direction of the AB, and theta 0 is equal to 1, then work done is equal to force into the displacement. Okay, when theta is 0, it means displacement is in the direction of the force, and theta 0 is equal to cos theta 1, then work done is equal to force into the displacement. Now if displacement is 90 degree, if theta is 90 degree and theta 90 is equal to 0, then work done is 0 because force into displacement, and here cos theta is 0, so force into displacement cos theta 0, the work done is 0. Now suppose in another condition, you are applying the force against the direction of the motion. Listen, your friend is going on the bicycle, you want to stop, then you hold the cycle in front of the, so force applied is the opposite direction of the motion, then theta is 180 and cos 180 is equal to minus 1, then work done is equal to minus F into S, that is work done is negative. So today I explained you work. I think it is clear to you because work done is always force into distance, and three conditions are there when the displacement is inclined. If theta is equal to 0, then cos theta is 1, then the work done is equal to force into displacement, and if theta is 90 and cos 90 is equal to 0, work done is 0, and if it is 180, that is cos 180 is equal to minus 1, then work done is negative. Okay, so I think work is clear to you. If you like my videos, please share and subscribe. Thanks very much.